Okay, we're going to take some notes on solving systems by graphing. So I would recommend that you get some color pencils because we're going to have to be shading things. So make sure you have a pencil pouch with some colored pencils in it, and follow along with the video and fill in your foldable notes as you go because you will need them in order to do the next examples and practice problems. Okay, so moving right along, assume you have your colored pencils. Okay, so our objective today is to solve systems by graphing. So a system, make sure you underline, highlight, do all of those important things that you do to make sure that your notes stand out to you. So a system of equations is a set of two or more equations or inequalities. So you have to have at least two of them because we're going to be looking for where they overlap or cross each other. Okay, so you can't do that if you only have one. So it has to be two or more. So make sure you have underlined this two or more. Now they can be equations or inequalities. So remember, just to help remind you, remember equations. If you look down in the next part, we have included that equations are anything with equal signs in them. And inequalities are things with inequality symbols, like a greater than, a less than, a greater or equal to, less than or equal to, all of those things. And if you have forgotten these, you can even fill these in underneath here. Remember, I always remember that this one, whoopsie, that's not even a thing. When you have that one, if you look at these two things, which one looks more like an L? I would say that this one looks more like an L. So this is your less than sign, and this is your greater than sign. So just quick review. And then remember, if it has the bar underneath there, that means or equal to. So that symbol that I just pointed to is a greater or equal to. So that means it could be greater than it or it could be equal to it, either one, and that'd be fine. Okay, so we have a solution. A solution is where they're going to cross, or a solution is all the points or a point that make all equations or inequalities true. So that means they're occupying the same space on the graph. So those are going to be your solutions. Okay, you underline, highlight that on your foldable. Okay. So let's go to the next section. Now this, all of these notes are not filled in on yours. So go to the first little section. It says solutions to linear equations. So in yours, your paper literally just looks like blank. I'm going to actually take a little screenshot so you understand you're looking at something that looks just like this. I'm going to make it over here really small so you could see it. So you are looking at this, right? You're going to make it look like this, okay? So you're going to have to, you can get a colored pencil and go ahead and highlight this line if you want. That's totally fine. You don't need to, but just put a little mark on that. But you do have to write all of this stuff on here. So a solution to a linear equation, so solution right here to a linear equation, this is what you're looking at, is all the points on the solid line. So on your paper, you're going to have to fill these notes in. So you would write something on this little marker. You're going to put all the points on the solid line. I'm just modeling for this first example. Just so you know, your picture, obviously mine is all filled in. I'm going to add some more stuff to it, but you're going to have to fill in these notes. So that is what you are going to be expected to do. So make sure you write down what I have written down on my screen right here. Okay, so it's all the points that are on this line. So if you just have one linear equation, all of these things, all of these points that make up this line, and even beyond here, because obviously you know this line goes forever, all of these are points that are on there, and they're all called solutions. So if you just have a single, any ordered pair x, y, so in this case, like if I'm to look at this point right here, This is the point 1, comma 1. That would be a solution to this linear equation because it lands right on it. Okay, make sure you have all the notes for this first little picture. And now we're going to move to the second picture. Now, once again, your picture doesn't look exactly like mine because mine is colored and I've already put the notes next to it. So your job is going to be to go ahead and color code it if you'd like, but definitely write these notes next to it. So let's see what we have here. We have a solution to system is going to be only where they overlap. So let's pause the video and write down only the point where they overlap. They must be on both lines. So if I look at this point right here where they overlap, right here, that right there is going to be the solution. It's the only spot where they overlap each other, right? I hope you're listening to the video because you can't even read my writing. So that right there is the solution. That is the only spot where this line and this line overlap. And that point is actually on both lines, isn't it? This pink point I just made right here is on the red line and it's on the blue line. So it is the only point that is common on both lines, only where they overlap. Okay, make sure you write all that down before you start the video. Okay, your next pictures. Okay, we have the solution to an inequality. Now remember, an inequality is greater than or less than. So it's going to be like above it or below it. And you may have learned in middle school that sometimes you'll have dashed lines like you see right here. And sometimes you'll have solid lines. If you look at this picture over here, it looks like we have a dashed line and a solid line. It does matter. So if you see something dashed, it actually means something different than solid. So don't just think that they're just drawing their picture fancy, because we do have a dashed line here. So take a look at this. Let's pretend like one side is shaded. Okay, so go ahead and get some colored pencil, something that's light. I have this blue, and go ahead and shade on one side of the dashed line. We're going to do the greater than side. So this is actually the greater than side. And that's a greater than sign. And it is just greater than because it is dashed. It's not or equal to. So this is the greater than side. So if I want to know the solutions, if I graph this in Desmos and I see this, all of the points in the shaded region are going to be solutions, or if it was a solid line. In this case, this is a dashed line. It says, but never ever points on a dashed line. So if I want to know the solutions to this inequality, it could be any point that's in this area. So go ahead and get some colored pencil, something, make a whole bunch of dots over here. These are all good points. Every single one of these that I'm doing is a solution. And it does keep going out here, right? Forever and ever, out to the sky. So every single one of these are good solutions. Now, if this line was solid, so it's going to be all the points in the shaded region. You wrote that down? So any point that I put out here in the shaded region or on a solid line. So this line over here is not solid, right? So we see that this is not solid. That means the solutions are not allowed to be on the dashed line. But if it happened to have been a solid line, it would be okay for me to put the dots on it. Okay, so make sure you have all of these notes, all the points in the shaded region, or if it was on a solid line. But I'm not going to put dots on this one because this one's not solid. And do include this note, but never ever points on a dashed line. I always think about points. They're not going to stay there. They'll fall right through all the little slats in between. So that means that all of these dots would be a solution we see. But like if I put a dot right here, that one would be not a solution because it's on a dash. All my other blue dots would be solutions. Okay, let's go to our third picture. Our third picture says a solution to a system. Now remember, a system has to have two or more graphs, right? two or more equations or inequalities. So if you look at this picture, we have a red one and we have a green one. So I would go ahead and get your colored pencils and shade them. I'm going to go ahead and do this red side. And this does go forever. I mean, it keeps going forever and ever just because you can't see it. And then we have this green side is over here, right? Now you might think it looks like there's three colors, this little area right here. This is the overlapping area, so it's not really a third color. It's just where the pink and the green blended together, so it looks a little bit like a different color. Okay, so let's take a minute to copy all these notes. It says all of the points in the overlapping shaded region. So overlapping is where the pink was and the green was. So our overlapping shaded region is going to be this area right in here, right? So it's all of these points. So all of these points in here are going to be all good, right? Any point in this shaded, double overlapping shaded region would be solutions, okay? All of these are solutions, all these blue guys, okay? Remember, it can be on a solid boundary of this little region I have over here, but cannot be in the dashed boundary ever. Okay, so let's see where these could be. So clearly all these blue guys would be fine, right? Now let's do some red guys that are going to not be okay. So you see over here, red, they're not okay because they're not in both the green and the red pink area. Over here is not okay either because they are not going to be, woo, my highlighter went a little crazy. This over here, it's not in the pink area, it's just in the green. So these red guys are not okay. Over here, it clearly is not okay because they're not in any area, right? So all of these blue guys are good. Now, remember, it is allowed to be on a solid line, but not on a dashed line. So this right here, if I were to put some points here, we would say no to these guys because they're on a dashed line. Never, ever on a dash. Now, if I put them over here, these blue guys would be okay. I'm going to put a little star here. These guys are okay because they're on a solid line, and solid lines are okay. Okay? Make sure you have all the notes. You might want to color code. See how the blue ones are the good ones. They're on this solid line or in the double shaded region, not on the dashed and not in the single shaded or no shaded regions. That's where the solutions are all blue there. Okay. Let's see what we got now. So sometimes we get some weird situations. Sometimes we get no solutions. So sometimes we'll have two solid lines. So grab a color. Sometimes we'll have this line and this line. What kind of lines are these guys? These guys are parallel, right? So these are parallel. So what's going to be true about parallel? Remember, they are never going to cross. Never, ever going to cross, right? So since they never cross, they never overlap, right? So that means that there is going to be no solution. So if someone gives you this picture, you would say there's no solution to this picture because these two lines will never overlap. They'll never share any points in common. This one, we're going to have to shade some areas in because these are some dash line. Let's pretend like when we graphed it, it looked like this. So get some colored pencils and let's shade on this side and then on this side. So pretend like we graphed this and we had this dash line and all this stuff was shaded on Desmos. And then we had this graph line and everything underneath it because this is the greater than sign, right? And this is less than because less than is below the line. So if we graph this in Desmos and this is what our screen looked like, we would also say there's no solution because remember that for it to be a solution, it has to be in the overlapping shaded areas. Now, do we have any overlapping shaded areas in this picture? We don't. There's no overlapping shaded. And we could see that these two are parallel. And this blue area is never going to combine on top of this pink area. So for both of these pictures, this is going to be no solution. So these are both no solution. Never overlap. Make sure you do shade this so you can see this in the picture because you can't tell from your plain white picture on your paper. Okay. Sometimes we also have infinitely many solutions. Oopsie. Oh my gosh. Okay. I must have hit something. I was trying to get rid of this weird OM that was sitting right here. Let me do it this way instead. Cut. I don't know. I must have typed something on there like a crazy person. Okay. So sometimes we have infinitely many solutions. And that means that the graphs might be on top of each other. So you can't really see it in here. So definitely get two different colors right now. I will use green and orange. So pretend like you graphed it and you have this orange line, right? And then you go ahead in Desmos and you type in the other equation, and it turns out that the other one is right on top of it. So when you draw this on your, they're both on top of each other. So make sure you can see both colors in your picture when you drew it. And you sure can tell on mine because I kind of made mine a little bit squiggly. But they're on top of each other. That means there's infinitely many solutions. So infinitely many means that there are so many solutions that you can never ever count them because this is a solution and this is and this and this and this and this and this and this. You see all the solutions because they always overlap each other. And you could keep going this way forever for the rest of your life, and you can go this way forever for the rest of your life. And so that's why there's infinitely many solutions. So if you get two graphs that are on top of each other, then that means they're going to have infinitely many solutions. Okay? So sometimes no solutions, sometimes infinitely many. Sometimes they cross just like this with two lines, so they only have one solution. And sometimes they cross with shaded areas, and then you have to look for the overlapping shaded. Notice we didn't pick this point right here, even though it kind of looks like the last picture where they cross, but that's not a good point because remember, it's on a dash line. And remember, never, ever, never, ever, never, ever, not ever, ever on a dash line. Don't ever pick something on a dash line. It'll fall through. Gone. Okay. Good for all those notes. Okay. Now we have some parts on the flaps. So we have some solid lines, some dotted lines. Okay, so let's talk about the solid lines first. So when you have a solid line, it's going to be equal. So it's going to be all the points exactly on it. So it's going to be all the points exactly on it. So get a colored pencil so you can see them. And these go forever. You got arrows, right? So it's going to be all points. Exactly on it, okay? So when you have equals, it's going to be all points exactly on it. Okay. Okay. And then we have this. This is a less than or equal to. So this is less than or equal to. That's how you read that. Less than or equal to. If you have a less than or equal to, it's going to be all the points on it and all the points under it. So it's going to be all the points on it and all the points under it. So I'm going to put a little note here on it and under it. On it and under it. So if you have a less than, which makes sense, it's less than. So I always think about like if this was like a roof and you had, it's going to be everything underneath the roof. Okay. Next one is, what's this guy? He is a greater than or equal to, greater than or equal to. And this one, obviously, it's going to be the points that are greater or equal to it. So that means we're going to have to go equal to it or greater. That's going to be above it, right? So all the points above it. Okay, so let's put a little note. It's going to be on it and above it. So all the points on it and above it. On it and above it for greater. Makes sense. Greater is above it, right? Now remember, if you have an equal sign in it, so you notice all three of these have an equal, right? See, this is an equal right here. I'm going to go ahead and draw it pink. You see this equal? Obviously. This also means equal, and this means equal. So anytime it has an equal, it's going to be a solid line. So notice all of these lines were solid. None of them were dashed. So make sure you have this note. If it has an equal sign, then do me a solid. Okie dokie. Okay, make sure you have all the notes and pictures too. You remember when you do your notes, you got to be extra. Be extra all the time because you won't be able to tell what you're talking about later if you weren't extra in your notes. Okay, dotted lines or dashed lines. Some people call them dotted, some people call them dashed, whatever you want, as long as you can recognize them and draw them. So a dashed line looks like this, or a dotted line, whatever you want to call it. This is simply a less than symbol. So you would read this less than. So less than means just the points under it. Less than is under it, not on it, because we already talked about this. You cannot get on the solid line. So that's going to be all the points under it. Under it only. Got it? Okay, what sign is this then? This is a greater than. Greater than. So that means you're going to have all the points that are greater than it. So greater is going to be above it, correct? So here I am above it. And remember, this does go forever. So feel free to keep going over the edge. Doesn't really matter because these have arrows, means it goes forever. So these are going to be above it only. Above it only. Okay, make sure you have the notes for all of these sections. You can rewind your video. Make sure you have beautiful notes because tomorrow we're going to do some examples and you have to apply all of the stuff that we just did.